Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is application security.
Definition. Application security refers to the practices, tools, and methodologies used to protect applications from security vulnerabilities, threats, and attacks throughout their lifecycle, from development to deployment and maintenance. The goal of application security is to ensure that applications are designed, developed, and deployed securely to prevent unauthorized access, data breaches, and other security risks.
Key concepts.
1. Purpose of application security. Application security aims to protect software applications from internal and external threats by addressing vulnerabilities in the design, development, and deployment phases. It involves implementing security measures to ensure that applications are resilient to attacks, safeguarding sensitive data, and maintaining system integrity. Prevent vulnerabilities. Application security focuses on identifying and mitigating vulnerabilities in applications that could be exploited by attackers to gain unauthorized access, manipulate data, or disrupt services. Secure sensitive data. Applications often handle sensitive data, such as personally identifiable information, PII, financial records, and intellectual property. Application security ensures that data is protected from unauthorized access and breaches. Comply with regulations. Many regulations, e.g., GDPR, HIPAA, PCI-DSS, require organizations to implement robust application security practices to protect sensitive data and ensure compliance with legal and industry standards. Support secure development. Application security includes secure coding practices, secure design, and continuous security testing to ensure that vulnerabilities are addressed early in the development process. Example: an online banking application implements application security measures, such as strong authentication, encryption, and input validation, to protect customer data and prevent unauthorized access.
2. Common application security vulnerabilities. Application security aims to address a wide range of vulnerabilities that can be exploited by attackers. Some of the most common vulnerabilities include SQL injection. SQL injection occurs when attackers inject malicious SQL queries into an application's input fields to manipulate the back-end database. This can lead to unauthorized access to data or even complete control over the database. Example: an attacker enters a specially crafted SQL statement in a login form to bypass authentication and gain access to a user's account. Cross-site scripting (XSS). XSS attacks occur when attackers inject malicious scripts into web applications, which are then executed by unsuspecting users in their browsers. XSS can be used to steal cookies, session tokens, or redirect users to malicious websites. Example: a vulnerable web application allows users to post comments without proper input validation. An attacker injects a script that executes in other users' browsers, stealing their session tokens. Cross-site request forgery (CSRF). CSRF attacks occur when attackers trick users into making unwanted requests to a web application where they are authenticated. This can lead to unauthorized actions, such as changing account settings or transferring funds. Example: an attacker sends a user a malicious email containing a hidden link that, when clicked, performs unauthorized actions on a banking website where the user is logged in. Insecure Direct Object References (IDOR). IDOR occurs when an application exposes internal objects, such as files or database records, to unauthorized users. Attackers can manipulate input values to access or modify data that they should not have access to. Example: a vulnerable e-commerce website allows users to change the URL to access other users' order details by manipulating the order ID in the URL. Broken authentication and session management. Weak or improperly implemented authentication and session management mechanisms can allow attackers to hijack user accounts or impersonate legitimate users. Example: a web application stores session tokens in URLs, allowing attackers to steal the token and hijack the user's session. Insecure cryptographic storage. Insecure cryptographic storage occurs when applications fail to properly encrypt sensitive data, leaving it vulnerable to unauthorized access. This can include weak encryption algorithms, improper key management, or storing sensitive data in plaintext. Example: an application stores users' passwords in plaintext, allowing attackers to access them if the database is compromised. Example: an online shopping platform implements input validation and parameterized queries to prevent SQL injection attacks, and it uses HTTPS to secure communications between users and the server.
3. Security in the software development lifecycle, SDLC. Integrating security into the software development lifecycle, SDLC, is critical for ensuring that security is addressed at every stage of development. This process is known as Secure SDLC or DevSecOps, where security is treated as a shared responsibility across development and operations teams. Requirements gathering. During the requirements phase, security requirements should be defined alongside functional requirements. This includes determining how sensitive data will be protected, how access will be controlled, and what regulatory compliance needs to be met. Example: during the planning phase for a healthcare application, the development team includes requirements for encrypting patient data to comply with HIPAA regulations. Design. Security considerations should be integrated into the application's architecture and design. This includes selecting secure coding patterns, implementing secure authentication mechanisms, and ensuring data is encrypted both at rest and in transit. Example: a financial application is designed with role-based access control, RBAC, to ensure that users have appropriate access to sensitive data based on their roles. Development, coding. Developers should follow secure coding practices to prevent introducing vulnerabilities into the application. This includes input validation, error handling, and avoiding hard-coded credentials. Example: a developer uses input validation to ensure that user input is sanitized before being processed by the application to prevent SQL injection attacks. Testing. Security testing should be integrated into the QA process, including vulnerability assessments, static code analysis, and dynamic application security testing, DAST. Penetration testing can also be conducted to simulate real-world attacks. Example: a QA team uses automated tools to perform static code analysis and identify potential security issues, such as insecure coding practices, during the development process. Deployment. Before deployment, ensure that the application is securely configured and that security controls, such as firewalls, access controls, and logging, are in place. Continuous monitoring and patch management should be part of the deployment strategy to address new threats. Example: a web application is deployed with HTTPS enabled, and the security team sets up monitoring to detect and respond to suspicious activity.
4. Application security testing. Security testing is a critical component of application security, ensuring that vulnerabilities are identified and remediated before the application is deployed. Common types of application security testing include static application security testing, SAST. SAST analyzes an application's source code, bytecode, or binary code for security vulnerabilities without executing the code. It helps identify security issues early in the development process. Example: a development team uses a SAST tool to analyze their code base and identify potential vulnerabilities, such as buffer overflows or hard-coded credentials. Dynamic application security testing, DST. DST involves testing a running application to identify vulnerabilities by simulating real-world attacks. It focuses on the application's runtime behavior and interactions with users and other systems. Example: a QA team uses a DST tool to test the login functionality of a web application for vulnerabilities, such as SQL injection or cross-site scripting, XSS. Interactive application security testing, IAST. IAST combines elements of both SAST and DST by analyzing the application's code while it is running. It provides real-time feedback on vulnerabilities as the application is being executed. Example: A security team uses an IAST tool to monitor a web application during testing to identify vulnerabilities in both the code and runtime environment. Penetration testing. Penetration testing involves ethical hackers attempting to exploit vulnerabilities in the application to simulate real-world attacks. This helps identify potential weaknesses that automated tools might miss. Example: a security consultant conducts a penetration test on a company's web application to identify vulnerabilities, such as broken authentication and insecure session management. Example: an e-commerce platform uses both SAST and DAST tools to ensure that its code is secure and that vulnerabilities, such as SQL Injection, are identified and remediated before the application is deployed.
5. Application security best practices. To ensure the security of applications, organizations should follow best practices for application security. Implement secure coding practices. Developers should follow secure coding guidelines, such as input validation, output encoding, and proper error handling, to prevent common vulnerabilities like SQL injection and XSS. Use strong authentication and access controls. Implement multi-factor authentication, MFA, and role-based access control, RBAC, to ensure that users have appropriate access to sensitive data and systems. Encrypt sensitive data. Encrypt sensitive data both at rest and in transit using strong encryption algorithms. Ensure proper key management practices to protect encryption keys. Conduct regular security testing. Perform regular security testing, including vulnerability assessments, penetration testing, and static code analysis, to identify and address vulnerabilities throughout the application lifecycle. Keep applications up to date. Ensure that applications and their underlying frameworks, libraries, and components are regularly updated and patched to protect against known vulnerabilities. Example: a healthcare company implements multi-factor authentication, MFA, for its patient management system, ensuring that only authorized users can access sensitive patient data.
Importance in the CISSP exam. Application security is a key concept within the software development security and security operations domains of the CISSP exam. CISSP aspirants must understand common application vulnerabilities, how to integrate security into the software development lifecycle, SDLC, and best practices for secure coding and testing. Exam questions may focus on preventing vulnerabilities like SQL injection, secure coding techniques, and the role of security testing in protecting applications.
Real-world example: a financial services company integrates application security into its development process by using secure coding practices, regular security testing, and encryption to protect sensitive financial data. The company conducts static and dynamic application security testing to identify and address vulnerabilities before deploying its online banking platform.